Okay, question number 35. This question is a bit lengthier, so not easy to solve it in 1 minute. Anyway, let me try it out. Okay, let me start the timer. A magnet connected to a spring oscillates above a solenoid with 240 turn coil shown. Okay, so now it is oscillating like this, up and down like this. The graph shows below the variation with time t of the EMF across the solenoid with the period t. So this is the graph shown over here. It has a peak amplitude V0 and a time period t. Okay, which means the question will also be focused or being concentrated within these two parameters. Right. The spring is replaced with a one that allows the magnet to oscillate with a higher frequency. With a higher frequency, which means what? Earlier, if the frequency was f, now the new frequency is f dash, which is f dash is greater than f. But look at the graphs over here. All of them will have amplitude, that is your current, and time over here. Okay. So therefore, when you look at this, f dash greater than f, which means t dash should be less than t. Okay. First clue we have got. So which means, look at the options here. Now before that, which graph shows the new variation with time t of the current I in the resistor for this new setup? Now t dash less than t. Where is t dash less than c? See here it is right, t dash less than t, and then here it's t dash is equal to t. So this is incorrect, and then here t dash is equal to t, incorrect. So this could also be the right option. Okay. So between these two, what is the difference? Here you see the current is I0. Here the current is greater than I0. Now let us go back to the previous graph. Here it is V0 over here. So V0 and I0 related. Okay. Now let us look out for how exactly it is being related on. We know that the flux phi is equal to NAB sine omega t. What is n? Number of turns, which is given as 240. A is the area, B is the magnetic field, and sine omega t is nothing but omega is the frequency, 2 pi f into t. So what is EMF? Induced EMF. Induced EMF is nothing but minus d phi by dt, right? When I differentiate this, I get this as minus NAB omega cos omega t. This is what I get. Now towards it, now you see this omega is nothing but 2 pi f, right? Where f is now frequency. Now in the new setup, what has happened? This f has increased over here, right? So when f is increasing, then automatically this whole quantity will also increase. Okay, this is EMF, of course I agree. The current I should be equal to EMF divided by resistance. So whatever happens here, EMF is definitely larger than the flux values. Wait just a minute, let me show you here. So here it is voltage, right? Here it is current. Okay, so definitely it is larger, and as a result of it, because this is omega, and as a result of it, this current will also become larger. And hence you observe, this is seen only in option A. Thus A is the right option, while D is the incorrect option. Okay, thus A is the right option. Let us move on to 36th